Step 6. Find either the p-value or the critical values and then draw and label the curve. Okay, now before we do that, let's talk about the critical region or the rejection region. That is the region that is shaded in a bell curve. This is the area that's corresponding to all values of the test statistic that cause us to reject the null hypothesis. Okay, now let's first talk about the p-value method. Okay, now with the p-value method of testing hypothesis, we make a decision by comparing the p-value to the significance level. Now remember, the p-value is the probability or the area that's in the shaded region. So in a hypothesis test, the p-value is the probability of getting a value of the test statistic that is at least as extreme as the test statistic obtained from the sample data, assuming that the null hypothesis is true. Okay, now caution though, don't confuse the following notation. The p-value again is a probability of a test statistic at least as extreme as the one found from the sample data, assuming that the null hypothesis is true. So again, the p-value is the probability or the area inside the shaded region in the bell curve. Now, the lowercase p is the population proportion, and p hat represents the sample proportion. Now, over here to our right, we can see a flow chart to talk about this and what it looks like for the p-value. So when we start, in order for us to start, we need to figure out what type of test. Is it a left tail test? Is it a right tail test? Or is it a two-tail test? Okay, so if it is a left tail test, over here you see that the p-value is going to equal the area to the left of the test statistic. So here's your test statistic, and then the area to the left of that would then be the p-value. Okay, now the right tail test, okay, if we want to use the right tail test, the p-value is equal to the area to the right of the test statistic. So the p-value represents the area that's to the right of that test statistic. Now, is the test statistic to the right or left or center? If it's a center, meaning that if it is two tails, then that means you would say the p-value is equal to twice the area to the left of the test statistic, or we can say the p-value is equal to twice the area of the right of the test statistic. The reason why it's twice is because when it's not equals, that means you have two tails, not one tail. Next, we have the critical value method. Now, with the critical value method, or traditional method of testing hypothesis, we make a decision by comparing the test statistic to the critical value. So, in a hypothesis test, the critical value separates the critical region where we reject the null hypothesis from the values of the test statistic that do not lead to the rejection of the null hypothesis. So therefore, in this case here, the critical region is the area of alpha, which is equal to 0.05, used to identify significantly high sample proportions. So the shaded area represents the critical region. Now down here, we would have the critical value. So we find that critical value. Now, if we have a test statistic, right, so you can see here that there's a test statistic and a critical value. So we have a test statistic, and let me go ahead and use a different notation here, or color, a test statistic, and then we have a critical value. Well, since we already have a critical value, we want to know where the test statistic is. So if we end up getting a test statistic, is the following. We can have two different test statistics. Now remember, if we're using a proportion, it could be a value of z. So let's say that z was equal to 1.25 as noted here. So if that was where they're pointing to here, it's not in the critical region, it's outside the critical region. Okay, that's if we had a test statistic that is outside of the critical region. And then what happens if we have a test statistic that is inside the critical region? So let's say we had 1.81. Well, then now it would be inside the critical region. Okay, so there's either going to be two scenarios. It's either going to be outside of the critical region or inside the critical region.